Hey Gophers, and welcome to another video of Stone Cold Math. Today we are starting a new geometry unit and we're focusing on circumference today. So our LEQ is, how can we use the circumference of a circle to find missing parts? One thing I want to point out about the word circumference is that the prefix circum is used in a lot of different areas. For example, we have explorers that circumnavigate the globe. So that should give you a clue as to what circum means. It should be going around. So before we go on, we're going to review a little what we know about area, because this year we're not going to get a reference sheet. You're expected to know the formulas. So let's start with a rectangle. If I needed to find the area of a rectangle and I had it measuring 4 meters by 10 meters, what that means is I would be taking this rectangle and I would cut it into 4 sections this way and 10 sections this way. And when I was done with those cuts, I would wind up with equal square units that were 1 meter by 1 meter. And I would wind up with 40 square meters. The reason that we say meters are squared is because not only are we multiplying our numbers together, but then we have to multiply our units together. And anything times itself is going to be that unit squared. So we get 40 square meters. When I'm asking you to find the area of a triangle, what I'm asking you to do is similar to a rectangle. If you can imagine that I have this rectangle duplicated, flipped, and extended on top. And what that would do would be give me a rectangle that measured 5 by 12. Well, if I find the area 5 times 12, I get 60, but then you have to go back and remember I only wanted half of that rectangle, just a triangle. So that's why our formula is 1/2 the base times height, because it's half of a rectangle. So I would wind up with 30 inches squared. So now that we've had a little area review, working with formulas, let's take a look at what we know about circles. If I asked you right now, what can you tell me about a circle? Or what is a circle? Most of you would say it's a round shape. I've had people today tell me it was a shape with no straight edges, a shape with no vertices, and that's correct. But, ready for this? A circle is a set of all points that are the same distance away from a center point, which is the center of a circle. So, a circle is a set of points that's the same measure away from a center point. What do you think we call that same distance away? Right, we call it the radius. So all of these points are a radius distance away from the center. That's how we measure circles, by how long the radius is. And let's talk about what happens if I extend that radius straight across. Not only do I have the radius from this center point to the edge and this center point to the edge, but because it's one continuous line segment, we call that the diameter. Just joking, we're going this way. So, 2 things you may or may not have known about the diameter. The diameter is equal to 2 radii. Radii is the plural of radius. Cactus, cacti, radius, radii. And the diameter is the largest chord in the circle. Now, chord is something that we learn later in 8th grade. A chord is any segment on the in the circle that extends from one point on the edge of the circle to another. So this would be a chord. I could have a chord here, but the longest chord in the circle is the diameter, because it goes from one point on the circle to another point and through the center point. the longest distance I can possibly draw inside the circle. That's called a chord. Okay, the distance around the circle is called the circumference. Remember we talked about circumnavigating? So it's similar to the perimeter of a polygon in that we're measuring how far all the way around we're going. Okay, there is a special ratio, and we know a ratio is a fraction. It's a comparison of two units. What do you get if you divide the circumference of a circle by the diameter of the circle? And it's not one of those corny pizzazz riddles. Let's go ahead and try that. If I have this circle and I tell you that the circumference is 88 centimeters and the diameter is 28 centimeters, I'm asking you to divide 88 by 28. Let's hold off on our answer for a second. Let's take a look at some more examples. What if I had a circle with a circumference of 132 inches and a diameter of 42 inches? So again, I'm asking you to divide the circumference by the diameter. Take a second and record that. And then try this one. What if the circumference of this circle was 37.7 centimeters and the diameter was 12 centimeters? Are you starting to notice a pattern? What are you noticing about the quotient? Specifically, if I had to round to the nearest hundredths place. And then think about what can we say about the ratio of the circumference and the diameter of a circle? We call that relationship pi. It's from the Greek letter pi. And it looks like this. The circumference divided by the diameter is approximately what we get for pi. Let's use this formula. We can use it for finding, we can use the same formula that we used for finding pi to find other parts of the circle as well. So if this is my main formula, this is the ratio of pi. If I had the diameter of the circle, I can use this to find the circumference. I would have to do some inverse operations, but my diameter would be equal to the circumference divided by pi. If I wanted to find the circumference and I knew the diameter, then I would use this formula. The circumference is equal to the diameter times pi. And because we know 2 radii equal 1 diameter, if I'm given the radius, then I would use this formula. The circumference equals 2 radii times pi. So any of those formulas can be used to find missing pieces. Here are some examples. Find the measure of the radius of the circle. Here's my circle, and my diameter is 14 inches. So while I know, you know at home what to do, I'm going to use the diameter equals 2r. I'm going to divide both sides by 2, and my radius is 7. This is a simple look problem. I know the whole thing across is 14, so half of it must be 7. If I'm asked to find the diameter and I'm given the radius, for example, 9 meters, well, I know that the diameter is 2 radii, so I'm multiplying straight across, and I get 18 meters. Okay. One other way to show a representation for pi. Sometimes they are going to ask us to represent pi, instead of using 3.14, they're going to ask us to use the fraction 22/7, which is another approximation. If you divide 22 by 7, you'll get close to the same representation of 3.1415, ... We use 22/7 if our radius or diameter is a multiple of 7. So here's an example. If I have to find the circumference of a circle with a radius of 21, it's going to be this formula that I'm using because I'm given my radius. I'm going to plug in the information that I have. My radius is 21 and my approximation for pi is 22/7. But do you see how using cross products I'll be able to simplify? 7 goes into 21 3 times, 7 goes into 1 once, 7 goes into 7 once. And when I multiply 2 times 3 times 22, my circumference is 132. If you substitute 3.14 here instead of 22/7, you're going to get a similar answer, but this one is more specific. It's more distinct. Okay, and that is all we have for circles. But we'll just click through instead of ending, because I'm so excited about my PowerPoint expertise until we turn off the video recording.